Topic 8, which is about acid, base, and salt. This is a very important topic. Why it is important? Because you will find like salt identification questions in the past paper, paper 6, and every year it is there and paper 6. So that's why this topic is having greater importance. So acid, base, and salt. First thing, the core idea that describe characteristic properties of acid as reaction with metal, base, carbonate, and effect on litmus and methyl. So characteristic properties of acids when they react with metal, so that will result in a formation of salt, and hydrogen gas is there. Acid plus metal, salt and hydrogen. Acid plus, how we know the color change pattern, the reaction. The color change, actually you have to learn these color changes, either from the substance which is formed. Mostly it is from the substance which are formed. Like example, just now we discussed in the last session, a redox reaction is there. So if iodine molecule is formed, you have to know, you have to learn the color for iodine molecule. Not all the reaction, but certain reactions you have to learn these colors. In chemistry, it's about 80% of memorization. Even though you understand when acid react with metal, it gives salt and hydrogen. But what color change, what you will observe, that or depends on the product which is formed. So acid react with metal, gives salt, hydrogen. So basically this salt which is formed is not a solid, it is soluble salt, aqueous. And if we want to remove the salt from the solution, we use crystallization or evaporation. Acid react with, this is metal carbonate, not only metal, give salt, water and carbon dioxide. And all, when acid react with metal, neutralization, all these three reactions which are above are known as neutralization reactions. And the salt which are produced depends on which acid is used. If we use hydrochloric acid, we produce chloride salt, nitric acid, nitrate salt, and sulfuric acid, sulfate salt. And the positive ion which is formed, which is present in a salt, depends on the base. Like example, if I'm using sodium hydroxide, then it will be a sodium salt. If I use potassium hydroxide, it will be a potassium salt. Then define acid and base in terms of proton, and this is limited to aqueous solution. Basically, the term neutralization is used when acid and alkali both reduce their properties. Like we don't have a medium which is neither acidic nor alkaline. That's why we call that as a neutralization. Like when acid is reacting with metal, why we call that also as a, that is also categorized as neutralization. Why? Because the properties of the acid is neutralized when it reacted with metal. Like it reduces its properties or make it neutral. Not, so not only it is valid for acid base, it is valid for all the three conditions. So define the term acid and base in terms of proton. Acids are proton donors and bases are proton acceptors. So sometimes they give you the equation like HCl is there mixed in water, and they ask identify a substance which is acid, or identify the species which is acid or alkali. So HCl become Cl, so it donate proton. That's why we call that as H2O become H3O, so it is accepting proton. That's why we call that as base. Then describe the meaning of weak and strong acid and base. So weak means they ionize but partially. Like, and how we can identify that it's a weak base. So when we pass the current, do electrolysis, it will not allow like greater amount of current to pass, few charges are present. So define acid and base. Acids are proton donors, bases are proton acceptors. So acids or alkalis which ionize completely, we call them as strong, and which ionize partially, we call them as weak. Describe the characteristic property of a base as a reaction with acid and with ammonium salt, and effect on litmus and methyl orange. When bases reacted with alkali bases react with acid, so it result in a formation of salt and water. Acid base reaction, which we also called a neutralization reaction. And effect on the on ammonium salt, what will happen when we add a base? Describe base as a reaction with acid and ammonium salt, and effect on the litmus and methyl orange. Like example, what happen if I have base such as sodium hydroxide and I add this to ammonium salt, say ammonium chloride. So what it result? It will result in a formation of ammonium hydroxide plus sodium chloride. And when I supply heat energy, when I heat, this ammonium hydroxide is not a stable compound, so this will decompose into water and ammonia gas. And what is the observation when ammonia gas is released? A pungent gas which will turn damp red litmus paper blue. That's why this is also a test for ammonium ion, that we add an alkali and heat, a pungent gas is released which turn the damp red litmus blue. So we confirm that the salt contain ammonium ion. And the color of methyl in methyl orange for alkalis, for methyl orange it will be yellow. Red litmus, if it is acid it will turn from blue to red. If it is like the solution, this red litmus, because we have litmus, blue litmus or red litmus. So red litmus is there. It, if a solution is acidic, it should be here red litmus. It will turn from red to blue. And blue litmus, it will stay as it is. Describe neutrality and relative acidity or alkalinity in terms of pH measured using a universal indicator paper, whole numbers only. Like uh, universal indicators show a color change at different pH. So a pH scale ranges from 0 to 14. If pH 7 is there, it will be neutral, less than 7 acidic, more than 7 alkaline. And the color, you should remember these color. Like example, if it is red, it is 1 2, or 3 is acceptable. Orange is there, it's about 3 4. Yellow is there, 5 6. Green, the universal indicator will be 7. 8 9 10, even 11 it is blue. And then violet, shades of the violet, that is uh, for pH 14. As we move from 7 to 14, it will become strong alkali. Like this side is weak alkali, the strong alkali, and weak acids and strong acids. Yeah, it is the same pattern like a rainbow: violet, indigo, blue, green, yellow, orange, and red. Whip cure. That's right. Describe and explain importance of controlling the acidity in the soil. So why it is important to control the acidity in the soil? Because the plants are growing normally in the neutral soil, neither too acidic nor too alkaline. And to overcome this acidity, what we add? We add a lime, or we can also add calcium carbonate for that. So if the pH of a soil is too low, it becomes too acidic. It means that the crops would not be able to grow in these acidic soil. So farmers use lime or calcium oxide to neutralize. But if more effective than lime, we can also use calcium carbonate. Calcium carbonate is more effective as compared to calcium oxide. Why? Because calcium carbonate is insoluble. So excess, if we add excess or more than enough, it will not make soil alkaline. But if we use excess of calcium oxide is sparingly soluble, and it will turn into calcium hydroxide. So excess of calcium hydroxide will make the soil alkaline. Types of oxides. You should classify oxides as either acidic, basic, related, metallic and non-metallic character. So acidic oxides, the non-metal oxides are also called acidic oxide, and metallic oxide or metal oxides are called basic oxide. And in a periodic table, when we move from left to right, the metallic nature changes to non-metallic. Metallic nature means they have tendency to transfer electrons. Non-metallic means they have tendency to share electrons. So what happened when it moved from left hand side to right hand side? The metallic character changes to non-metallic character, or the type of oxide changes from basic to acidic. And further classify other oxides as neutral and amphoteric. Neutral, which does not react with neither acidic or alkaline. So you are only learning one example, that's carbon monoxide. An amphoteric, such as aluminum oxide, lead oxide, and zinc oxide. They can react with both acid and alkali. But keep in mind, there are other amphoteric oxides as well. You are not learning all of them, only the three: aluminum, lead. If any other than this oxide is given, they will give you a detail that a certain oxide is not reacting. Like zirconium oxide is also amphoteric, so does not react with acid or it does react with acid or alkali. So they provide the information. Preparation of the salt which you want to prepare, it depends on which kind of salt we are preparing. So which kind of salt you are preparing? If you are preparing a soluble salt, so the methods which are reactions, all the reaction of acid can be used to manufacture those salt. But except like the first method, if I want to prepare a copper salt, like I cannot mix copper metal with uh, acid. Reason for that, because copper does not react with dilute acid. So first method for copper salt cannot be used, but other acid react with metal oxide, metal carbonate, metal hydroxide can be used for preparing those soluble salt. And if you want to prepare insoluble salt, that is called ionic precipitation, and ionic precipitation is used, means you mix salt solution with salt solution, or you mix salt solution with acid. Acids are also aqueous, so basically mixing two solutions and a solid is formed. That's why we call that as precipitate. So demonstrate the knowledge and understanding of preparation, separation, and purification of salt. Example, some techniques specified in section 2.2.2, the reaction specified in section 8.1. So the reaction which are specified in 8.1, these are the reaction, the classification, like acid plus metal, carbonate, these reactions are there. Demonstrate the knowledge and understanding of preparation of insoluble salt by precipitation. suggests a method of making a given salt from suitable starting material and given appropriate information. So this is related to planning of experiment as well as preparing a salt. With this a summary for the part. Now demonstrate the knowledge, understanding and preparation, separation and purification of the salt. So what we will do, first we will add excess of base, the salt from insoluble base. Insoluble base here means like we can have metal here, we can have metal oxide or we can have metal carbonate. All these are refers to insoluble base, a solid. So and add an excess of base to acid. So what we will do, we have a container, a beaker which is filled with acid. We add, using a spatula, we add a metal, excess of metal or base or metal oxide or metal carbonate until no more react. So until no more react, all of the acid is used up. Then we'll filter to remove unreacted base. So we'll do filtration and remove this. What we are left with, we are left with salt solution. So when we are left with salt solution, we can do two methods. Either we can use crystallization or we can use evaporation. Normally we use crystallization because if I want to evaporate all of this liquid, it takes a lot of energy and time to practically obtain a salt. So short, simple method we use crystallization. We'll filter to remove unreacted, then heat the solution and leave it warm to evaporate the water and allow the crystal to form from a soluble base. Or we can also, a technique which we use for salt from soluble base. So soluble base means the base is aqueous. And in this one we use a titration, the technique which we use to identify what volume of acid is reacting with an alkali, because both acid and alkali are colorless. So we use this technique. We can either use a pipette or a measuring cylinder and transfer acid or alkali. Example, I transfer acid to a conical flask, so this will have acid. Then we will add drops of indicator. It will, like if I add phenolphthalein, it will be colorless in acidic medium. Then we will fill the burette. We'll fill the burette with an alkali. How you'll identify whether it's a burette or a tap funnel? A tap funnel is not having, number one, tap funnel does not have labels. Burette is having labels like marking. And second thing, when a solution is added by using a tap funnel, it is completely inserted in the flask. Like if I was having a tap funnel, because both of these apparatus look similar, but a small difference is there, that the tap funnel is completely inserted into the flask, where burette is having some gap is there between the flask and the. So this is a tap funnel without any label, but burette is having label, and there's a gap between the flask and the burette. So we add acid, we add an alkali until indicators show a color change. Once indicators show a color change, we know what volume of acid is reacting with an alkali. Then we'll repeat the procedure without indicator and use crystallization to obtain the crystals. Then how we can form two, by mixing a two solutions, how we form a salt. So make first, what we'll make, an insoluble salt is formed by precipitation. It means a solid form from solution. We will mix the two solutions, they will form a salt, and we'll remove the solid by filtration, and then we will wash the solid, because this solid is not soluble in water. So we wash the solid and then we will left it on the filter paper to dry, or we can use a desiccator or oven to dry quickly. Identification of ions and gases. Describe the following test to identify the aqueous cations. Aluminium, we add sodium hydroxide. Use a flame test to identify lithium. It is red in color. Sodium, it is yellow in color. Potassium, it is lilac in color. And copper, it is blue or green is also acceptable. So only four elements you have to learn the flame test according to course syllabus outline. And test for carbonate, we add acid. Test for chloride, bromide, iodide, we add silver nitrate or lead nitrate can also be used. Test for nitrate ion, we add aluminium, sodium hydroxide followed by aluminium and heat. Test for sulfate ion, we add barium nitrate or barium chloride. Test for sulfite ion is SO3. We add hydrochloric acid and aqueous potassium manganate, which release color change will observe purple to colorless, which release sulfur dioxide. So these are the tests for the ions. You have to learn this table if you want to obtain insoluble salt from base example. Yeah, example we have as Mohsin you asked this question, we have HCl. So practically, Mohsin, this technique is not suitable. Why this technique is not suitable? Example, you have sodium carbonate, which is solid, and you mix that. Example, you have HCl, which is aqueous. You mix sodium carbonate, which is solid. It react and form silver chloride, which is solid, liquid, and gas. So practically, this is not a right way to obtain a salt. Why? And why we don't call this as a precipitate? Because here we mix solution with solid, so it's not called a precipitate. So practically, it's difficult to separate these two solids from each other. That's why we do not use this method to obtain insoluble salt. Is it clear? So if a question, I think you have this question from an MCQ. They ask which technique is suitable to prepare a silver salt. So why this technique is not suitable? Because two solids are there. One is before, which you use in axis, and the one which is formed during a reaction. So hard to separate the two solids from each other. So it's not a hand pick method. That's why it cannot be useful. Then you have to learn when we add sodium hydroxide, few drops. If aluminum is there, white PPT, it will dissolve. Ammonium ion, we add sodium hydroxide and heat. A pungent gas turn red litmus blue. Calcium white PPT. No change here means insoluble, does not change or no does not dissolve in excess. Chromium 3 is a gray green precipitate, form a dark green solution. Copper 2 blue precipitate, iron 2 green precipitate, iron 3 orange brown precipitate, and zinc white precipitate which dissolve. With aqueous ammonia, we can also not need to identify other ion. Only with aqueous ammonia, aluminium is there, white PPT, no change, calcium, no precipitate are formed, and zinc white PPT which redissolve. But with aqueous ammonia, now they are asking according to what will happen if copper 2 is there, because copper 2, the white PPT dissolve, the blue precipitate dissolve and it will form a royal blue solution. So flame color for lithium crimson red, sodium is yellow, potassium is lilac, and copper is green. But blue is also acceptable, but green is the practical color of this. Then the test for iron carbonates, when we add acid it will give fizz. Halides, we add silver nitrate, or we add the why we add this acid first. If any carbonate is there, so it will remove that carbonate from the solution. Nitrate, so we add aluminum powder and add sodium hydroxide and heat. Ammonia gas is there, but we can use other metal, react copper, aluminum, zinc alloys. Sulfate is there, we add barium nitrate or barium chloride. White PPT. Sulphide is there, it give off sulfur dioxide when we add acidified here aqueous potassium manganate, and there will be a color change from purple to colorless. Test for gases: ammonia dim red litmus blue, carbon dioxide lime water milky, chlorine dim blue litmus. It will turn first red and then bleaches, remove the color. Hydrogen is there, it pop with lighted splint. Oxygen is there, glowing split, it will relight. And sulfur dioxide, it will decolorize. Potassium manganate 7. So this was topic 8. Then the topic 9 is about the periodic table. In a periodic table, describe the proper periodic table as a method of classifying element, and it used to predict the property of element. So how we can use a periodic table? The periodic table can be used to classify and predict the properties. Elements are arranged on the basis of atomic number. As in elements in the same column or group, they have similar chemical properties. Like group 1, 2, 3, 4, and so on. And using a group number, you can deduce the number of electrons in the outermost shell. This staircase is actually showing the elements which we call metalloids. Metalloid means they have some properties resemble with metal and some of the properties resemble with non-metal. That's why we call them as metalloids. Describe the change from metallic to non-metallic character across the period, and describe and explain relation between group number and outer shell electron and metallic and non-metallic character. So when we move from left to right, the metallic character changes to non-metallic character. Group number shows the number of electron in the outermost shell, and how we can identify whether an element is a metal or non-metal. If it is having few electrons, like example 1, 2 or 3 electron in the outermost shell, we categorize that as metal. If more than 3, then we categorize as a non-metal. So from left to right, the element changes from metallic to non-metallic. And what are the characteristics of they have shiny, conductivity, dense and malleable. On either side of a red line, there are some elements which we also call metalloid. They have similar properties. Some properties resemble with metal and some properties resemble with non-metals. Then the group number shows the number of electron in the outer shell. Metals form a positive ion, they lose electron, and non-metals form a negative ion by gaining electron, except group 8. Group 8 does not tend to lose electron or gain electron. It's complete shell. Then properties: describe lithium, sodium, potassium of group 1 as a collection of relatively soft metal, showing a trend in the melting point, density, and reaction with water. The metalloids are placed. These are the metalloids. They're in the groups. Why they're in the groups? Like example, there are some metalloid in group 3, group 4, group 5. But why they're placed not separately? Because the number of electron, according to number of electron, they are arranged in a group. This staircase line, elements above and below this staircase line are metalloids. So for group 1, Predict the property of other elements in group 1. Melting point, what happened? When we compare their melting point with other metals, they have low melting point. And as we go down the group, the melting point decreases. Why the melting point decreases? Because positive ions are getting larger in size, so they cannot attract their electron. In a weak electrostatic attraction is there between the positive lattice of a positive ion and electron. That's why the melting point, as we go down, it decreases. Density, they have low density compared to other metals. When you compare with other metals, they have low density. And as we go down the group, the density increases. Density for all groups, as we go down the group, because there are more particles, more proton, neutrons, so mass of atom increases. That's why overall density will increase as we go down the group. Reaction with water, as we go down the group, the reactivity increases, vigorous reaction. So usually more bubbles when they react with water, as they are releasing hydrogen and turning a solution. You can mention this as well, but in terms of density is electrostatic attraction between the lattice of positive ion and the free electron. Because you have to explain why the melting point is getting or melting point is lower as we go down, because the size is larger, so weak attraction between the lattice of the positive ion and the free electron. The reason why you should use the term lattice of positive ion, because they have a metallic bonding. So metallic bonding is basically, it's a electrostatic attraction, but basically it's the attraction between the lattice of a positive ion and free electrons. So when we go down the group, the reactivity increases, and when they react, like example, when lithium react with water, it will form lithium hydroxide. So if we add an indicator, it will turn blue. And it is forming a hydrogen gas. Look, the net charge on the ion, when you compare lithium is smaller, in lithium positive ions are smaller in size, and the net charge, resultant charge, is +1. When you compare the same size potassium, potassium ion is larger in size, and the attraction of electron is toward the nucleus, because nucleus is positive. So net charge on the it's +1. So the nucleus net charge is +1 and electron is far, so they have greater distance. So weaker attraction towards the nucleus. But this is smaller in size, so greater attraction, that's why high melting point. Yeah, that's I'm repeating. When we go down the group, why the melting point is decreasing? When you compare the size of the ion is smaller. Okay, so this smaller size ion is attracting the electron. That is the metallic bond. And attract, not only it is attracted towards this electron, attracted towards this one positive ion, it is attracted towards all the nucleus, but it will have a stronger attraction. But when you compare, in case of potassium, which is having a larger positive ion, so electron attraction towards the nuclear or the positive ion, as the distance is greater from the nucleus, that is why weaker attraction, so it will have a low melting point. Sodium will have high, or lithium will have high melting point. Is it clear? Yes, Hashim, that's right. When the size is bigger, because the tendency of a metal is to lose electron when they react. So when they are bigger in size, weaker attraction, so it can easily lose electron. That's why when you compare, if you have a lithium which is having electron in the outermost shell which is closer to nucleus, and potassium away, when they react they tend to lose electron. But you can clearly see, because for potassium electron is far away, so it can easily lose electron. That's why it will react fast, and lithium relatively will react slower. Then describe halogen, uh, chlorine, fluorine, chlorine, bromine, and iodine, group 7. They all exist as a diatomic, like you will find fluorine as F2, chlorine Cl2, bromine Br2, and iodine I2. Relative, the reactivity decreases as we go down. Why the reactivity decrease? Why the reactivity decrease as we go down? Because these are non-metal. Non-metal tend to gain electron. So chlorine is smaller in size, bromine is larger, iodine is much larger. So when they tend to gain electron, smaller size, so it can easily attract electron. That's why chlorine will react fast and iodine will take time to attract, so it will react slower. And always the more reactive halogen displaces the less reactive. Like example, chlorine with sodium bromide, so it will form sodium chloride. This is for all non-metals, but you are learning only for group 7. What is the meaning of a shielding effect? The term shielding effect means when the nucleus is shielded by electron, like surrounded by more electron. The If I say I have a nucleus, say this is a nucleus which is having neutron and proton, okay? An electron is placed here. Say this electron experiencing the attractive force of say 20 newtons. But now what happened? There is a nucleus which is having same number of proton and neutrons, and it is surrounded by electrons in the shells. So as there are electrons in the shell, so this electron which is in the outermost shell, it will not experience the same force. Why it will not experience? Because like charges repel. So these electrons try to push it away, and nucleus is attracting. So resultant force on this electron will be less. So greater the number of inner shell electrons, greater the shielding effect. This effect is called a shielding effect. That electron, due to the presence of inner shell electrons, does not experience the force which it should experience. So always the more reactive halogen displaces the less reactive halogen from its compound. You have to learn the color: fluorine, chlorine, bromine, and iodine. As we go down, the density increases, the reactivity decreases. For transition element, they have variable oxidation state, catalytical property, form colored compound. And for group 8, you should learn the uses. Helium is there. It is less than and not reactive. So used for weather balloons, neon advertisement lamps or signs. Argon, krypton, xenon are used in filament lamp. And these are the comparison of metal and non-metal, and transition metal with group 1. Transition metal are physical compare. This is a physical. They are much harder compared to group 1. High tensile strength means greater force is needed to break them. High melting and boiling point. These are physical comparison. Chemical comparison, they are less reactive. They can resist corrosion. They show variable oxidation state, catalytical property. Leave the magnetic part because you are not going through that. So this was periodic table, topic 9. Next session, next class, we will do topic 10. Any question related to the class today?